So how do we do this? See how they're talking about the greatest integer function here. And I actually don't like that name. I'm going to write it down though. The name of this function, this symbol, is the greatest integer function. But what all that is rounding down. So my preferred name for this is called the floor. Just call it the floor function. And my preferred symbol for this is this. Because you see it's like a bracket with only the thing on the bottom. Because that signifies that it's the floor function. But what this is it's rounding down. So if we have a graph. Whoa. If we have a graph. This looks like this. It's like steps. So like here is 1, here is 2, here is 3, here is 4, here is 1, here is 2, here is 3. So see, like when it's inputting anything less than 1, it's rounding it down to 0. Anything greater than 1 but less than 2, between 1 and 2, it's rounding it down to 1. And then it continues down here, this pattern. Well, they all connect, so like that. So then when we picture this graph, we can talk about what's going to happen. As x approaches 0 from the left, so let's say the limit as x approaches 0 from the left of f of x, we'll look at the graph. It's negative 1. But then from the right of f of x, it's 0. And that's just by looking at the graph. Here you see from the right, it's going to 0. Here from the left, it's going to negative 1. So this graph isn't used very often. It's used as an example sometimes in calculus. Some people talk about it. I didn't talk about it in Algebra 2 just because I thought it was a distractor from the more important part of transformations. But like you can do it sometimes. This is an example. We're doing all the examples. So that's what you do. You just got to picture the graph like always.